Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to write mathematical expression in the Earth Engine JavaScript environment. So, in this tutorial is organized for the beginners, and also I prefer to use the most typical satellite data. However, you can use the tutorial material for all other satellite data or products available in the Earth Engine platform. So, in the first step, you must call a kind of satellite data you want to work. According to the previous tutorial that is published on my YouTube channel, you know how to search about the data and products. For example, in this tutorial, I'm going to work with Sentinel-2 images. Go to search places on dataset and type for Sentinel-2. So, as you can see, two types of products available regarding Sentinel-2. One of them is level 2A, the other one level 1C. Level 2A is already corrected radiometrically and atmospherically. That's why I'm going to use level 2A Sentinel for this tutorial. Import it into the code and then make a variable for the imported collection. Here it is. We have Sentinel2 variable equals to the image collection, just like that. So if you want to get information about the data, just click on the data link and then you can see all necessary descriptions and information about the kind of data you're going to work. So back to the code. Then we must select an area as a region of interest. For example, I'm going to select Helsinki as a region of interest for this tutorial. So as you can see, drawing tools available here, and you can use the drawing tools to select your region of interest. For example, throw a rectangle. I'm gonna make a polygon or a rectangle like this to call those satellite data covering Helsinki region, Helsinki metropolitan area. So let me to make it a little bit bigger, just like that. So now you must use filter bound to bound your data or satellite images or filter your satellite data based on the rectangle or this geographical location. That filter bound, I'm gonna filter data based on a geometry already created. Then you must filter your data based on period of time you're gonna work. For example, I'm gonna work on satellite data available for 2023. 2023 start date and end date is 2024. So let's make a print from Sentinel2 variable. In the right panel, after a few moments, you will see an image collection. In the previous tutorial, I talked about the image collection and its difference with the image, and also what kind of a structure do we have in the image collection. All of them already explained in the previous video. So I'm suggesting you, if you want to get more about the image collection and structure, go to the previous video on my YouTube channel. So here, as you can see, more than 800 elements for satellite image from Sentinel-2 available for this period of time. According to the properties, we can throw the information already existed in the properties. We can make a cloud filter for the satellite data to deal with those of satellite images with the lowest cloud cover possible. For example, cloudy pixel or the land percentage. This is a good property that we can filter our data based on. So another filter as less than filter created here. So the property name is cloudy pixel over land percentage, and as it is the less than filter, the value could be, for example, less than 10%. I'm gonna use those of Sentinel-2 data for the Helsinki for 2023, in which cloud cover is less than 10%. This is a kind of data I'm gonna find to work with. Run a code again, and after a few moments, only 134 images remains. So, in the next step, even you can limit your data to a period of time. For example, you can use satellite data in which the vegetation cover is maximal. For example, during the summertime. That's in this case, you can change the filter date to limit it to summertime from, for example, July to August, for example. Or you can pick any other period of time that you want to use. The target in this tutorial is not about the vegetation analysis or something like that. The target is how we can call satellite data, how we can do expressions, and also how we can get exports. So here from July to, for example, September 0901. So there it is. If you run a code, only 100 images available. So we have 112 satellite images for the summertime in which cloud cover is less than 10%. Now we want to find a way to do some sort of calculations or the write and expressions. When you are dealing with the image collection, you must make a loop structure for writing the expressions. For example, here, as you can see, .map is that function that allows you to make a loop structure. So, and if you want to write an expression or if you want to do a process on each satellite data available in the variable, you must make a function inside the loop. The inputs for the function can be called with any names, such as img, item, image, or on, and also etc. So here, in the function structure, first I'm gonna write different type of expression that gives you insight about writing expressions and equations in the Earth Engine platform. If you go to the data properties, for some of the satellite data, there is a scale factor value that should be applied on each band before further calculations. So this is the first expression I'm gonna write. I'm gonna select all bands or multispectral bands, and then I need to make a multiplication process between the band and also the scale factor. So make a new variable as bands equals to, from each input image, I'm gonna select the multispectral bands. Go to the features and select one of the images, and as you can see, the multispectral bands highlighted with B and the sequence number, B1 to B12. It's very simple. Here I can select all the bands starting with B and the rest no matter. So after bands selected, now we want to multiply the multispectral bands to the scale factor value. So the simplest way is using multiply function. As you can see, you can do multiplication using that multiply function. If you want to add something to the bands, you can use that add, just like that. If you want to subtract a value from a band, we use subtraction. So if you want to divide each band to a single or a specific scale values, in that case you can use division dot divide. So but here we want to multiply a scale factor to each existing band. Dot multiply, inside the parenthesis you must write the scale factor value. There it is, 0.000 and 1. So this is a kind of expression that you can write using built-in functions or built-in scripts available in the Earth Engine environment. So in another example, I'm going to show you how to write a more complex expression through the, for example, through the arithmetic signs or mathematical operators. If you go to the developers.google.com, there is a page about the image math and also the expressions. The link of this page already actually highlighted in the description box below below the video on my YouTube channel, and you can click on and directly go to this page to get more information about arithmetic operations or operators that you can use for the calculations. And also there are very good examples here that enables you to actually find useful information about expressions. So as you can see, now I'm going to show you how to use arithmetic operators to do some sort of calculations. For example, imagine that I'm going to calculate the normalized difference vegetation index. So the NDVI equation is like that. So we have a numerator and denominator. In the numerator, we have near infrared subtracted from the red, and also in the denominator, we have an addition between near infrared and red. So I'm going to write this equation using Earth Engine operators. There are different ways to write these operators, to write this equation simply. So the first method is like that. So call the bands already corrected. Then through the expressions, you can write your expression, your desired expression, using arithmetic operators available here. So now we can write the NDVI equation just like that. Near infrared minus red, near infrared plus red. So now the expression is ready, but there are unknown variables, or there are unknown items, NIR and red, all of them are unknown, that should be actually introduced using the bands we have here. So the existing bands already stored in the band variable. So here you must define the unknown variables. One of them is NIR equals to from bands dot select. As you may know, the band number 8 is the near infrared for NDVI, B8, and the red one is equals from bands select the band number 4. As I mentioned in the previous video, if you want to get more information about the bands, you must go to the data page, go to the bands. Here the information about the different bands, the wavelengths, the spatial resolution, and also their name is already available. That helps you to find the appropriate bands for your equations. So the red one is band number 4, just like that. So this is a simple method to write the expression using arithmetic operators available in the JavaScript. And finally, you can rename it as, for example, NDVI. But it is not limited to this way. There are other ways that enables you to do some sort of calculations. One of them is, for example, the built-in functions we already introduced. For example, imagine that we want to calculate the NDVI using such kind of functions. Here, another variable we will have as NDVI number 2 equals, so from the input bands dot select first near infrared band or band number 8 dot subtract, that must be subtracted from red band, from the bands select band number 4. So here is the numerator that should be bounded to parentheses, then divided to addition term between near infrared and the red. Here we will have the bands that select, as you can see, band 8 that add from bands that select the red band 4. There it is. This is another way for writing an expression in the Earth Engine platform. So this is the NDVI number 2. So, and there is another format for calculating for some sort of calculations in which we have a normalization structure. When you have two variables and you want to get normalized relationship to highlight their differences, you can use normalized difference in the Earth Engine platform. Another one is NDVI number 3. So here from input bands, you can use the normalized difference. The normalized difference is actually works like this. First, you will introduce two kind of variables here. Band names, for example, I will have band number 8 and band number 4, near infrared and red, just like that. So first you introduce band 8 and band number 4, and then normalized difference calculates the normalization relationship like this for the input bands or the bands you introduced before. This is another way for doing some sort of calculations in the Earth Engine platform. Finally, we can rename it as the third NDVI. So, at the end, the function returning one of the parameters, or you can return all of them together. We can change their name to NDVI1, NDVI2, and NDVI3. Return NDVI1, or you can make a stack layer using earthengine.image.cat, just like this, in which including band number 1, band number 2 or NDVI number 2 and NDVI number 3. So, with the properties of input images. As you saw before, we had properties for each data, and we want to keep them for the output for each date. Remember to save your code and run it again. Again, you will have the same image collection. However, there are different bands this time, NDVI 1, 2, and 3. All of them calculated using the methods we already introduced here. So, when you want to write some sort of expression, this is the simplest way, or these are the typical ways that you can use for the calculations. So, but now I'm going to show you how you can write these expressions or how you can do this kind of calculations for a single band. It is also very simple. Imagine that here we have 100 112 images, and we want to use one of these data as a single image and write the calculations just for that image, not make a loop for whole of data and making a function and write it like this. So now I'm gonna make a new variable only for a single image, a variable as sentinel2 img. So here you can see the IDs for each existing image separately. For example, this is my target image based on the date. As you can see, the date of this data is related to, for example, September 2023. Imagine that this is my target image, and I'm gonna bring this image as a single image or single element into Earth Engine and do my calculations using the different methods already introduced here. So just first make an image structure using Earth Engine.image and copy the ID that you can see here and paste it inside the quotation marks. Then print sentinel2 img to make sure that band actually extracted, or that image already extracted well or not. Here, as you can see, we have only one image in that's including 26 bands. So if you want to select the target bands, it is very simple. Just make a new variable as sentinel2 bands, sentinel2 bands equals to get sentinel2 img first, select your target bands starting with B, just like this, and then we want to calculate, or we want to actually apply the scale factor using multiplication or any other ways that you prefer. So here, for example, imagine that after the band selected, you can even use the expressions just like this to apply the multiplication or to do the multiplication process for each band available here. img multiplied to the scale factor. img is unknown, should be introduced here inside parentheses. The img equals to sentinel2 img all existing multispectral bands starting with B. So if you get a print from sentinel2 bands, in the right panel you will have one image with 12 bands. As you can see, that's already a scale factor applied on each available band, just like this. So this is a same calculation, but this time we are doing this calculation only for one image, only for one single image, not inside a loop structure. So now you saw that how we called image collection, how we selected one single data, and also how we did calculations using the loop structure. And now I'm gonna show you how to do this, how you can do this calculations only for one element or only for one image. So now we want to calculate the sentinel2. Here sentinel2 ndvi equals to bring sentinel2 bands already corrected, and then through the normalized difference we'll be able to calculate a normalization relationship between near infrared and the red band, band 8 and band 4, and finally rename it as an NDVI layer. So print sentinel2 NDVI, for example. In the right panel you will have one image with one band including the NDVI. So if you want to visualize this data, it is very simple. Just try with map.add layer. Couple of arguments we have here. So maybe you ask these questions, or this question raised, how I show the arguments or necessary or optional arguments automatically. It is very simple. Just for example, when you write the function or when you are writing the function, if you press Control and Space together, the rest of the codes will show. And now if you want to see the arguments inside the parentheses, again press Control Space. Here the object I want to visualize is Sentinel-2 NDVI. Leave the visualization parameters empty or you can set, for example, a minimum or maximum, but I prefer to leave it empty because in the next tutorials I will show you some tips and important techniques about the visualization process. In this tutorial, I'm gonna show you how you can do expressions and also how you can visualize it. That's enough. So, and the layer name is, for example, the NDVI, and the shown should be true because actually the shown should be false because I'm gonna show the result because I'm not going to show the result automatically because it reduces the speed of processing in the Earth engine. So save your code and run it again. So after a few moments, under the layers, you will have NDVI image for the Helsinki, but that NDVI image not covered Helsinki area completely. But as you can see, only a part of this image covered the Helsinki area. But anyway, you can see the vegetation cover here very well. That's highlighted with the white color. And also in another video, I will show you how to do the mosaic process. No matter, just in this video, I was going to show you how you can do some sort of calculations and how you can visualize the final results. There it is. And also the code example is available below the video on my YouTube channel. If you had any questions or problem, you can compare yours with mine. And also you will find a lot of examples about the expressions through the another link I have attached for you. Here there are a lot of examples about the operators and also the arithmetic and others operators available here for writing equations. I'm highly suggesting to use these tutorials that highly helps you to improve your skills for data analysis in the Google Earth Engine platform. Thanks for your attention, and also keep following my YouTube channel to get more information and skills about the Earth Engine capabilities.